Organic chemistry. Now, as the word suggests, these molecules were originally discovered in organic material. So they were discovered in plants and animals. They were isolated, and that's why they were given the name organic. And then nowadays, when we think of organic chemistry, we think of carbon chains, and we think of often fossil fuels and crude oil. Okay, so the organic chemistry obviously led to the investigation of the composition of fossil fuels, coal, oil, natural gas. People realized that they came from the decayed remains of organic material from millions of years ago under the ground. And essentially these fossil fuels are made up of molecules, carbon chains, from one carbon to many, many carbons, all of different lengths. So they're a big mixture. Crude oil is a big mixture. Sometimes crude oil is called petroleum. Crude oil is a big mixture of molecules with carbon chains of different lengths. Now we've seen mixtures before, the classic mixtures. Air is a classic mixture, isn't it? Air is a classic mixture. And crude oil is another classic mixture. We'll talk about how we separate the components of this mixture in a minute. So there you go, that's more or less where the energy comes from in the world at the moment. The biggest chunk obviously comes from oil, natural gas and coal. Little by little, we're moving towards energy being produced by wind power and that'll be biofuels. We've got to do something about this, though, haven't we? Clearly, there's a bias towards fossil fuels that we have to move away from if we're going to deal with global warming. So, molecules, carbon, different lengths. These molecules, these compounds, they burn in very exothermic reactions, and this is why they're excellent fuels. And a hydrocarbon, this is a definition you must remember, is a molecule made up of hydrogen and carbon, hydrocarbons. So the majority of things in these oils and coals are hydrocarbons. Methane is the most simple, we've seen it before. So you have its molecular formula, which is CH4. And then we're going to start talking about full structural formula, or displayed formula, as they're sometimes called. This is called a Lewis structure, don't worry about that. And it shows that it's got 4 single covalent bonds. Carbon's valency is satisfied, 4, and hydrogen's valency 1. These you will have seen in many films, and essentially what they are, this thing goes up and down. They're just pumps. They pump oil from under the ground, they pump it to the surface. Enormous pumps. Okay, so once they get the holes drilled into the oil reserve under the ground, then the only thing they have to do is pump it up to the surface. Okay. Propane. Now you need to remember that alkanes, well, several homologous series, we'll talk about them, but you need to remember things like methane, ethane, propane, butane, pentane, hexane. You have to remember the names. A good mnemonic, I'm not a big fan of mnemonics, but a good mnemonic is monkeys eat peanut butter. Monkeys, methane, eat ethane, peanut, propane, butter, butane. They're the first 4. And those are the ones you'll come across the most. So, propane, its molecular formula, monkeys eat peanut. 3 carbons, so its molecular formula is C3H8. The dot and cross diagram, it's important you can draw these things. Have a go at the dot and cross diagram. Try and satisfy the needs of the carbon and the hydrogen. Okay, so it looks like that. Each carbon's got 4 single covalent bonds. Each hydrogen's got 1. And they arrange and everything is satisfied, isn't it? Structural formula. In this case, the full structural formula looks like that. Propane. How do we separate these hydrocarbons in crude oil? Well, they're separated by fractional distillation. The hydrocarbons, the HCs, the hydrocarbons have different boiling points. So whenever we have a mixture of liquids with different boiling points, we can separate them using fractional distillation. Okay, so each of the collections of hydrocarbons at different levels of the fractionating column, each of these collections is called a fraction. So for example, at the top here, you've got refinery gases. Okay, now you need to learn these particular things. I know it's a lot of information, but you need to learn that at the top you get refinery gases, which is methane, ethane, propane, butane, and that goes to be bottled gas or natural gas. Okay, and then the next fraction is gasoline or petrol, and that's fuel for cars. Naphtha is for making chemicals. Kerosene, aircraft fuel. Diesel, fuel for cars, lorries and buses. Fuel oil is used for ships and for power stations. And then the residue is called bitumen, and it's a thick black tarry substance used for roads and roofs. I've spelled that wrong, by the way. Okay, so you need to remember these. The fractions, when you get these fractions out, you can actually further process them, make more useful and reactive molecules using cracking. But we'll talk about cracking in a minute. So these are the fractions, you need to learn them. Look at the temperatures. It's hot at the bottom, it's cool at the top, and that's what separates the different components according to their boiling points. At the top you get low boiling point, volatile, not viscous, and quite explosive hydrocarbons, methane, ethane. They will explode if they're mixed with oxygen. Okay? If they're a liquid, the higher you go up, the less viscous they become, the lower the boiling point. As you go down, they become more viscous, higher boiling point. They're not as volatile, they don't flow, and they're more difficult to ignite. Right, essential chemistry. Look at the pages indicated.